Okay, it's going.
Okay, cool. I can answer the first one.
Okay.
What is a confidence interval? And I showed that it's commonly used. It's a commonly used interval estimator.
Yeah. And then what is the margin of error in a confidence interval when estimating the population mean? And it's the margin of error is half the width of the confidence interval.
Awesome. Okay, assuming you know sigma, what is the general formula for a confidence interval used to estimate the population mean? X bar plus or minus Z times sigma divided by the square root of n, or square root plus or minus m.
Right. What are the assumptions for creating a confidence interval for a single mean with sigma known? A simple random sample was drawn from the population, X bar is normally distributed, and sigma is assumed to be known.
Awesome, okay. Go to the normal probability applet and type in 0.90 for the area. Shade the middle area under the curve, leaving the two tails unshaded. Record the positive z-score below the nearest hundredth. I got 1.645.
Okay, and for 0.95, it's 1.960.
And 0.99, 576.
And then what happens with the z-score as the area in the middle under the normal curve increases, it gets larger.
3 assumptions that need to be checked before you compute a confidence interval for a mean. Those are just the same as before, right? A simple random sample. Yeah, X bar is normally distributed, or whatever is normally distributed, and sigma is assumed to be known.
So what is the point estimate for the population mean for that paragraph above? It's 541.
Okay, create a 95% interval, confidence interval for the population mean. Show your work below. This I did not understand how to do it. Same equation as number 3.
Yes.
Yes. I just didn't know which numbers exactly to put in. So did you get this one? Did you understand this one okay?
Yeah. Mm-hmm. Yeah. So it's 541, so you take the mean, so X bar, minus, then that 95% is the one up above, the 1.960. Times 32, which is sigma, divided by the square root of 50, because there was 50 students.
Okay. I'm just terrible at knowing what number is what. You know what I mean?
Right.
I just need to memorize it better, and I don't know. And then you did plus or minus, and that's how you got 532.
Right. So figure out the 1.96 times 32 divided by the square root of 50, and then do 541 minus that and 541 plus that.
Okay. Where did you get the 1.9? Oh, 0.95.
The 95, yeah, confidence interval.
Okay.
5% in the applet.
Okay, that makes sense. And then you do the same thing. The next one, you do the same thing, but you put 100 in for n.
Right.
Okay. I'm going to try that after we do this, and so I can get the answer and understand it. Okay. Going to do number 10?
Yeah, so how does the margin of error for the 95% confidence interval, a sample size 50, compared to the margin of error for the 95% interval, the sample size of 100? And so it's larger, the margin of error gets smaller as the sample size gets larger. And so you'll find out that for 8, the margin of error it's 532 plus some, and to 535. And then for number 9, it's 534 to 547. So as the sample size got larger, then the margin of error got larger.
Okay. So create a 90% confidence interval for the original 50 students. Same thing, but just different numbers, huh?
Yeah, so now you're 90%.
Right.
Changes.
So I wrote down the answer from the answer sheet, whatever, 533.556 and 548.444.
Yeah,
Is that what
yeah, I always get like a little bit different number. I don't know why. I don't know if my calculator
right?
rounds differently, but I got pretty much the same thing, but
All right, cool.
yeah.
Yeah.
So then it says, how does the margin of error for the 95% confidence interval that you computed in question B compare to the margin of error to 90%? And it is smaller, so the margin of error gets smaller as the level of confidence grows smaller.
Okay. Again, the BYU professor would like to repeat the experiment, but he wants to make sure he has enough students in his sample to ensure that his margin of error is 5. How many students will need to be in his sample to ensure he has this level of accuracy for 95% confidence interval? This one, I actually have no idea how they got this number, 158.
So that is taking your 95%, so the 1.96 times 32, so times sigma, and you divide it by 5, which is your margin of error, and then you square it.
Wow.
So that was, and that's in the book, in our reading.
In the reading.
Mm-hmm.
Okay. Awesome.
That's how you figure out N. So that's how you figure out your sample size if you want to know what your sample size should be to get that. So the formula for that.
Okay. I struggle with so many equations. I really do. I just don't get how they even,
Yeah.
you know what I mean? Just having all these different things and trying to memorize them for tests.
Right. That's the hard part, is like trying to remember, because then when you on number or chapter 11, I can do all this like in SPSS, but then when you have to like remember how to do the formulas, then it's like, oh my gosh, I don't even remember how to get standard deviation. I don't remember how to do this. So it's like, I can't do it longhand anymore. I can do it all and get all the answers. And so, all right.
Okay, so I guess we can do the quiz now.
Okay, I need to get in there. Oh, I can't. Sorry, it's taking my computer load up a little bit here. Okay. Do not round. Okay, so find the margin of error for a 90% confidence interval when the standard deviation is 50 and the sample is 25.
So we're going to use that 1.6 or 1.6545. Do we use that same thing when that we got for
right, 1.645. So 16.45.
Yeah.
So which of the, oh, go ahead. You can get to the next one.
Which of the following statements is true? Sigma squared is an internal estimator of X bar. X bar is a point estimator of mean. Mean is a point estimator of X bar. Sigma is an interval estimator of sigma squared.
Oh boy. That's a good question.
Let's see. Yeah, seriously.
That one I'm not sure about.
Neither. Mm-mm.
Okay, as an interval estimator of X bar is a point estimator of mean.
Hmm. I have no idea. Let's see.
So I think it's X bar is a point estimator of mean.
Okay. Let's see. I think you're right. Are you on the reading?
Mm-hmm.
Yeah, that little chart.
Yeah.
You see that little chart with point estimators? Yeah. I think you're right. And I mean, we have a second chance, so.
Right. Okay, Gina wants to construct a 95% confidence interval for GMAT score. She knows the standard deviation. She collects a simple random sample of 64 and computes X bar as 526. Uses information for the next 6 questions. What is the point estimate for the true GMAT score? So that's 526, right?
Yeah.
What is the margin of error for 95% interval for the true GMAT score?
Well, that's the. So now we do that equation, right?
Right.
So what would be Z for this then?
So 95% is 1.96.
Oh yeah. 113 over square. Oopsies.
So 27.685.
Oh, sorry, I'm still figuring it out. Let me see. What did you say you got?
27.685.
Yeah, I got that too. What is the lower limit of this confidence interval? Round to 3 decimal places.
So 526 minus 27.685.
498.315.
Yes. So then the upper limit, oh, oops, is 526 plus 27. Oops. Use that up. 553.685.
Yep. What would happen to the width of the confidence interval if Gina increased the sample size? Wouldn't it increase too?
Yeah, wait, if we increase the sample size, yes, then it grows, yes, it increases. What would happen to the width of the confidence Gina? What would happen to the width of the confidence interval if Gina changed it to a 99% confidence interval? So if it gets
99 instead of 95, wouldn't it also increase?
yeah.
Okay. Bright Bulb Light Bulb Company is planning a study to assess the average life expectancy of their light bulbs. They know the standard deviation is 400 hours. They want a 95% confidence interval with a margin of error of 50 hours. What sample size do they need? Round up to the nearest whole number.
Okay, so that's the
One. So do 1.96, right? Times is that what it is? 1.96 times
times the standard deviation, is that right? Divided by 50 squared. $246.
oh, 1 second. Oops.
So
Time. Oops.
1.96 times 400 divided by 50 squared. I believe that's correct.
I was just sorry. I'm doing it on my phone, and so it's cooking me. Oops. And what did you say you got?
245.86. So rounded up to 246.
Great, awesome. Yeah. Okay.
Let's see, the mean salary of actuaries is $100,000 and the standard deviation is 36,730. You are interested to know if the mean salary for women actuaries is different from the population mean, but are not sure if it is higher or lower. You set up a hypothesis test with the level of significance 0.05. And your null hypothesis is 100,000, and your alternative does not equal 100,000. You collect a simple random sample of 36 women's salaries and find X bar equals $111,000. What is the lower limit of this 95% confidence interval? Round to the nearest whole number. Okay.
So 1.96 times 36,730. Is that what we're doing? Yes.
Yes.
Deviation divided by 100,000 or no, 30.
Divided by
We do the
square
sample size.
root of the sample size, 36.
Okay.
So 11998.466667. So the lower limit is
And we subtract that from what number?
the 111,000.
Oh, right.
And we're rounding the whole number. So 99002.
Mm-hmm.
And so then the upper limit is 122,998.
Okay. Okay. Great. Okay, there are 3 requirements that need to be checked when computing a confidence interval for a mean. They are sigma, I think it's all of the above,
Yeah.
right?
Yep.
Okay. Great. You know, we got one wrong. Got number 9 wrong.
Oh.
Let's see.
Decrease the sample size.
Oops. Oops. Okay, so let's do this all over again. Want me to read them to you, the answers to you? Or do you have them there?
I got him. It's just gonna take me a sec here. I'm in now. Make sure I'm on the right one.
Yeah. you been posted? I just finished it. And we got 100, putting decrease
Okay.
there. So,
Okay.
have you been posting the group collaborations on the on that board?
I have,
Have you? Because I've been getting zeros for it. Have you been writing who's been in attendance?
Yeah.
Or do you not have?
I
Yeah?
put
Weird. I'll email the teacher.
okay, I put yours and my name.
Funny. Yeah, I'll email him. 'Cause I've been getting zeros, which is
Really?
weird. Yeah.
Huh.
Yeah. And I've been. I mean, I think I missed like lesson 4.
Right.
And maybe I missed lesson 5, but I don't think I think I've been here for the past 3 weeks. I'll figure it out.
Yeah. I should go check and see if I've been getting it.
Yeah. Next, my grade is dropping, and I was like, we've been getting hundreds for the,
Right.
you know.
Right. Yeah.
Yeah, I mean, I've been here since, week 5. I don't think I was here like week 4, but weird. Yeah, been getting zeros ever since week 4, which is goofy, but I'll email him.
Let me check and see what I've been getting.
I assume you're getting the points since you're the one posting them. I was here week 4 too, so I don't get it. Yeah, I'll tell him I was here for every week.
Yeah.
You've been getting the points?
Yeah, I didn't get, well, group for lesson 4 and lesson 5, that was the week. Oh, I didn't get points for it. You know what? Because I didn't post anything on the boards. I emailed them. That was the week you guys were out of town.
Okay.
But lesson
Oh,
6 and
right,
7.
right.
Yeah.
Yeah, lesson. Okay, yeah, because I wasn't here for lesson 4,
Yeah.
right?
Yeah, lesson 4 and 5. But lesson 6 and 7, and then lesson 8, there wasn't one. Yeah. Yep, and I put your name on it and put attended.
Okay.
So
Yeah, because I have for lesson 4, lesson 5, lesson 6, and lesson 7, I got zeros. So I just need to tell him.
Yeah.
So I've been here for lesson 6 and 7.
Yeah.
Right?
Right.
Lesson 4 and 5, I wasn't. I'll email him.
I'll go
Oh, that's a little bit frustrating. I need all the points I can get.
I know, right? Exactly.
Okay, awesome. Well,
Yeah. Let me go double
got
check.
it. Cool. So we
oh wait, you should have it for lesson 9 because we're on 10 and 11 too. Yeah, group collaboration, but he hasn't graded that yet.
Yeah, but I was here for 6 and 7, which he has. So I'll.
Okay, yeah.
Email him.
Sierra Robinson, right? I'm putting the right name, right?
Yeah, I looked. Yeah, it's on there. So.
Okay, yep.
Cool. All right. Well, we'll meet next Tuesday then.
Well, we have to.
Tuesday, Thursday.
Today's Tuesday.
Oh my goodness! I thought today was Thursday. We'll meet on Thursday.
Yeah, perfect.
Oh, that's how my week is going. My goodness. Okay.
Okay.
Sounds good. I'll see you Thursday.
Okay. Bye.